All right, now we're going to talk about the two interactions on a covalent bond. One is called a polar covalent, one is called a nonpolar covalent. Now, a polar covalent bond is when there's unequal sharing of electrons. And that's going to, remember, this is all happening between nonmetals. So polar covalence happening between nonmetals. When you have unequal sharing, it'd be like if I had The Rock, the sexiest man alive this year, The Rock is next to me, and he's huge, big guy. And my arms are locked with The Rock. Well, if he pulls on me and I pull on him, I'm not going to pull him. He's going to pull me closer to him. That's exactly how a polar interaction is. It's an unequal sharing of electrons. The one that's more electronegative is actually going to pull the other one's electrons closer to it, and it's going to develop a slight charge. It's not a full-on ionic charge. It's just a slight charge called a dipole-dipole interaction. Okay, a dipole-dipole interaction. How we show that is with, I've been looking at this for years, and I can't tell if it's a funky S, like a slight charge, a slight positive, and a slight negative, or is it a weird-looking D that stands for dipole, a positive dipole and a negative dipole. But either way, the one that's more electronegative is going to get the slight negative. So we learned about electronegativity in our last chapter, the trends. The more electronegative from left to right, and it's more electronegative from bottom to top. And we said fluorine is the most electronegative. So in this interaction here, the one that's the slight negative is going to be fluorine. The one that is slightly positive is going to be the chlorine. In this one right here, oxygen and sulfur, oxygen is slightly negative, sulfur is slightly positive, and in this one here, nitrogen is slightly negative, and phosphorus is slightly positive. It won't always be right to left like that. If nitrogen was here and phosphorus was over here, then this would be slightly negative and that's slightly positive. Okay, and that is called a polar covalent bond, and that is going to matter when we get into how things interact with each other, like how they dissolve in each other and stuff like that, because polar things will dissolve polar substances. And so when you're making compounds, the polarity of that matters. All right, now when we get to nonpolar, nonpolar is an equal sharing of electrons. So you're going to have two of the same nonmetals. So in this one, the examples you could see with polar were two different nonmetals. This is two of the same nonmetals. So if I have a twin brother and he's the same size, same height, same weight, everything, and we pull, we're not even going to pull each other. We're just going to share each other equally because we're exactly the same. Well, that's exactly how these are. So because chlorine and chlorine are bonded together, there's no slight pull on the electrons. It's an equal sharing of electrons, so there is no slight charge. There's no dipole. And because there's no dipole, okay, you don't have to draw the interactions. All right, so the things like chlorine bonded to chlorine, nonpolar. Oxygen bonded to oxygen, nonpolar. Nitrogen bonded to nitrogen, nonpolar. So things that are equally sharing are nonpolar. All right, now, when you see that, there's also, you're going to see for the honors kids, electronegativity differences. So if you have an electronegativity difference, if the electronegativity difference, if you look up on the chart, the order of electronegativities, if it's less than 0.3, okay, if it's less than 0.3, then it's nonpolar. If it's between 0.3 and 1.6, then that is polar, a polar interaction. And if it's greater than 1.7 electronegativity difference, then that is said to be ionic. Now, when you go to college, this is how you judge whether something is nonpolar, polar, or ionic. You look at the chart and you see the electronegativity differences. This is high school. And so in high school, what we look at is it two of the same nonmetals? If it is, then the electronegativity difference is going to be 0. And so it's an easy nonpolar C. Okay? If it's two different nonmetals, then it's going to be polar. And if it's a metal and a nonmetal, that is going to make ionic. Because remember, on the opposite side of the table, you're going to have the biggest electronegativity differences, and that's going to make an ionic. So it's going to be metal and nonmetal, two different nonmetals and two of the same nonmetals for nonpolar. All right, so that is our lesson on polar and nonpolar covalent.